In this video, we are going to solve 3 more problems related to trigonometric identities. So please pause the video and give it a try yourself. And also, if you like these videos, please share it with your friends and also help this channel grow. Thank you. Okay, I hope you paused the video and tried it out yourself. Let's look at the solutions now. So here, in the first one, we have to prove that 1 by secant square x minus cos square x plus 1 by cosecant square x minus sin square x times sin square x cos square x is equal to 1 minus sin square x cos square x divided by 2 plus sin square x cos square x. So if you notice the right hand side, we only have sin square x and cos square x. So what we'll do is, on the left hand side of this equation, we will change all the values to sin or cos. So let's change secant to cosecant and secant to cos and cosecant to sine. So let's start with that. So the left hand side would be 1 by cos square x minus cos square x plus 1 by sin square x minus sin square x times sin square x cos square x. So now let's solve for the common denominators. So we would get 1 divided by 1 minus cos to the power of 4x by cos square x plus 1 divided by 1 minus sin to the power of 4x by sin square x times sin square x cos square x. So let's divide or move the denominators to the numerator when it switches from denominator to numerator. So this would change to cos square x by 1 minus cos to the power of 4x plus sin square x by 1 minus sin to the power of 4x. Now we have to consider this too, sin square x cos square x. Now let's solve for the common denominator. So this would be cos square x times 1 minus sin to the power of 4x plus sin square x times 1 minus cos to the power of 4x divided by 1 minus cos to the power of 4x times 1 minus sin to the power of 4x times sin square x cos square x. So how can we solve this now? So this is of the format a square minus b square, both of these, right? So, and we can multiply the numerators with the respective values available. So this will be cos square x minus cos square x sin to the power of 4x plus sin square x minus sin square x times cos to the power of 4x. So that will be our numerator. Now the denominator, we will split it to a square minus b square is a plus b times a minus b. So let's split it now. So this will be 1 minus cos square x times 1 plus cos square x, and this next part will be 1 minus sin square x times 1 plus sin square x. Then we already have here sin square x times cos square x. Okay, now 1 minus cos square x can be changed to sin square x. 1 minus sin square x can be changed to cos square x, because we know that sin square x plus cos square x is equal to 1. So this is a primary identity. So let's change that part. So also one more thing we can do is cos square x plus sin square x can be changed to 1. So a couple of things we are going to change now. 1 minus cos square x sin to the power of 4x minus sin square x cos to the power of 4x divided by 1 minus cos square x, we are rewriting it as sin square x, and we will retain the next part 1 plus cos square x, and the next part 1 minus sin square x, we are replacing it with cos square x, and the next part is 1 plus sin square x, and sin square x times cos square x. So we cancel out the sin square x and cos square x here. Now let's see what else can be done here. So, okay, we have cancelled that out. What else can be done? Okay, now in the numerator we have cos square x can be taken as a common from both these terms, and sin square x can be taken as a common from both these terms. So let's do that. This will be 1 minus cos square x sin square x times cos square x plus sin square x, correct? Divided by, now let's multiply this, both of them. So what happens if we multiply? We would get 1 plus sin square x, then plus cos square x plus sin square x cos square x. I just multiplied these two together. So now we can change this part to 1 again, and this will change to 1 because of the identity. So now we will have 1 minus cos square x sin square x divided by, so this will be 1 plus 1, 2 plus sin square x cos square x. So this is what we wanted to prove. This is your right hand side of the equation. Please comment if you have a different solution in mind, or let's go to the second problem. Thank you for watching up to this point. Now let's solve the second problem. Here we have to prove that if 2 sin x divided by 1 plus cos x plus sin x is equal to a, then 1 minus cos x plus sin x divided by 1 plus sin x is also equal to a. So basically we have to prove that these two equations are equal. So let's start with the information that is given to us, which is 2 sin x by 1 plus cos x plus sin x. So we have been told that this is a. Now if you see the equation that we want to achieve, it has 1 minus cos x plus sin x in the numerator. So, but we have no way to achieve that unless we multiply and divide this equation by what is in the question. So we will multiply and divide it by 1 plus sin x minus cos x divided by 1 plus sin x minus cos x. So this does not change the value of the equation because we are multiplying as well as dividing it. So that becomes 1. Now if you notice here, if we combine 1 plus sin x as a and cos x as b, if we consider this is nothing but a square minus b square format, correct? Which is a plus b, a minus b. So let's apply that now. So let's multiply the numerators. So what would we have in the numerator? It would be 2 sin x times 1 plus sin x minus cos x divided by the denominator would be a square minus b square, and a is 1 plus sine x. So 1 plus sine x the whole square minus cos square x. If you have any confusion, please pause the video and try to figure it out yourself. How do we rearrange these values in the format of a square minus b square is equal to a plus b times a minus b? I know it's tricky sometimes, but with more practice, you will easily be able to do all these solutions. Now let's apply this a plus b the whole square here. So this will be 2 sine x times 1 plus sine x minus cos x, the numerator, divided by 1 plus sine square x plus 2 sine x minus cos square x. Now cos square x can be again changed to sine square x by applying the trigonometric identity. What is that trigonometric identity? It is cos square x plus sine square x is equal to 1. So cos square x is 1 minus sine square x. So if you apply this here now, it would be 2 times sine x plus 1 plus sine x minus cos x divided by, the denominator would be 1 plus sine square x plus 2 sine x, and this would be minus 1 plus sine square x, because minus cos square x is minus 1 plus sine square x. Now let's see what we can change here. So the ones would get cancelled and the denominator would have 2. We can add this. It would be 2 sine square x. So we will have 2 sine x times 1 plus sine x minus cos x divided by 2 sine x plus 2 sine square x. Correct? Now 2 sine x is common between these two parts and the numerator. So you can cancel this and one of the squares. Correct? And the 2 will be cancelled. So we will have 1 plus sine x minus cos x divided by 1 plus sine x. Is that the equation we wanted to have? Yep. So basically what we did is we changed the given equation 2 sine x by 1 plus cos x plus sine x to this part. So that means both are equal to a. So this is how you can prove that both the equations given in the question are a, because they are equal to each other. Let's solve the third problem here. So here we have been given the information that tan x is b by a. We have to find out what is the value of square root of a plus b by a minus b plus square root of a minus b by a plus b. So we somehow have to apply this tan x and find the value of what would be the square root b. So now let's start to solve it. So we know the ratio b by a is equal to tan x. So we somehow have to get b by a applied in the square roots. So let's divide the entire square, divide both the numerator and denominator by a so that we get b by a. So this would be 1 plus b by a by 1 minus b by a plus square root of 1 minus b by a 1 plus b divided by a. So now we know that b divided by a is tan x. So this will further change to, let's apply tan x now, which is 1 plus b by a changes to tan x, and this will be 1 plus tan x by 1 minus tan x. That's in the square root plus the second part of the equation. This will be 1 minus tan x divided by 1 plus tan x. Now let's solve for the common denominator, or rationalizing the denominator as they call it. We just have to cross multiply the denominators here, and we would have, so square root of 1 plus tan x multiplied by square root of 1 plus tan x, we will have 1 plus tan x, the square root goes away. Similar case applies to the second part, which is square root of 1 minus tan x multiplied by square root of 1 minus tan x. We will have 1 minus tan x. And if you notice the denominator, it is a minus b and a plus b. So we will have square root of 1 minus tan square x. So now the tan x in the numerator gets cancelled. So we will have 2 divided by square root of 1 minus tan square x. So you can have this as your answer as well, because you cannot simplify it further. The best you can do is change tan x to sin x and cos x. So we will have 2 divided by square root of 1 minus sin square x by cos square x, correct? And if we solve this, we will get 2 cos x divided by square root of cos square x minus sin square x. So this is the best you can achieve here by applying tan x. So this will be your answer for the third one. Thank you for watching this video. If you like it, please share it with your friends and also subscribe to the channel. It helps me to make more videos and help you guys with the trigonometric functions. Thank you for watching. I'll see you in the next video.